In a previous video, we have talked about introduction to the set. In this video, we will talk about various operations that we can perform on the set. So some of the operations like union, intersection, complement, difference, De Morgan's law, Cartesian product, partitions, etc. we are going to talk. Venn diagram is visual representations of the set operations, and it was proposed by John Venn in 1880. And Venn diagram is typically represented by circles. Circle indicates one set. So consider yellow is set A, blue is set B, and green is the region which is overlapping. So that green region indicates the common elements in set A and set B. Yellow elements are unique element in A, blue elements are unique element in B. Union operation between two sets is performed by considering all the elements of both the sets. So whatever area which is enclosed in red border, that indicates A union B. A intersection B represents common elements between both the sets. So that green region is common in both the sets, that is enclosed by red border. A complement intersection B. So A complement indicates all the elements which are not in A, and that we have to take intersection with all the elements of B. So all the elements which are highlighted in blue represents A complement intersection B. If we have multiple sets, then also we can extend the concept of Venn diagram. For three sets H, F and W, H intersection F would be this region, H intersection F complement. So that would be anything other than the output in the previous diagram, and that we are complementing, that we are taking the intersection with W. So that is what's shown here in red border, and H intersection F intersection W complement. So we will take the respective intersections, and what we'll get is just this much red region. Now we will consider all the operations with example. Mathematically, we can represent A union B by all the elements X, where X is member of A or X is member of B. So if element is present either in set A or in set B, then that will be part of A union B. On right hand side, we have some data. X is the universal set or the universe of discourse, which contains 1 to 9 element. Set A is having 1 to 5, B contains 3 to 6, and C contains 6 to 9. For A union B, we have to take union of set A and set B. As we know, set contains only unique elements. So even though few elements like 3, 4, 5 are repeated in both the sets, we have to write down it only once in the A union B. So finally, A union B would be 1 to 6. And the Venn diagram for this is shown here. The outermost rectangle represents the universe of discourse, that is capital X, and both the gray regions indicates the output. So inner rectangles are sets, outer rectangle is set of universe, and gray region indicates the output of the operation. So A union B contains all the elements from A and B, so entire region is shaded. A intersection B is defined by all the elements X such that X is member of set A and X is member of B. So here the condition is that element must be present in both the sets. For given data, A intersection B would be 3, 4, 5 because those elements are common in both the sets. And graphically or using Venn diagram, we can represent it in this way. The shaded region is common in both the sets A and B. So that is what the output. A bar or A dash or A complement. It is also known as an absolute complement because we are complementing the set with respect to universe. So that is given by X minus A. So it is collection of all the elements X such that X is member of X and it is not present in A. So we have to remove all the elements of A from X. That will give us the complement of A. So A complement would be 1, 2, 3, 4, 5, 6, 7, 8, 9, that is X, minus we have to subtract A from that, that is 1, 2, 3, 4, 5. So these 5 elements we have to remove from X. So A complement would be 6, 7, 8, 9. So everything other than A would form the complement of A. A minus B is called difference or the relative complement. It is collection of elements X such that X is member of A and X is not member of B. That means you can also represent it using A minus A intersection B. So we have to consider only those elements which are in A but not in both. So A minus B is given by 1, 2, 3, 4, 5 minus B, that is 3, 4, 5, 6, and we are left with 1, 2. Graphically we can represent in this way. So elements in A should be there, but common elements we have to delete from it. Symmetric difference A symmetric difference B is defined as elements X such that X is member of A and X is not member of B, or X is not member of A and X is member of B. We can also represent the same operation using the mathematical equation A union B minus A intersection B. So A union B here is 1, 2, 3, 4, 5, 6. We have already computed. A intersection B is 3, 4, 5. And symmetric difference would be difference of these two. So that would be 1, 2 and 6. Graphically we can represent it like this, that A union B minus A intersection B. So common elements from A and B we have to delete. Rest of all from A and B would be member of A symmetric difference B. A union B whole complement is given by A complement intersection B complement. So this is De Morgan's law. So A union B is 1, 2, 3, 4, 5, 6 and complement of that would be remaining elements in X, that is 7, 8 and 9. So left hand side we have computed. Let us compute A complement, which is 6, 7, 8, 9. B complement is 1, 2, 7, 8, 9. And intersection of both of these is 7, 8, 9, which is RHS. You can verify that left hand side and right hand side gives the same elements. So De Morgan's law is hold for given equation. So this is how we can represent in using Venn diagram. A complement intersection B complement. So all the elements which are not in A intersection, all the elements which are not in B. So gray region is the output of the operation. The second law of De Morgan, that is A intersection B complement, is same as A complement union B complement. A intersection B is 3, 4, 5 and complement of that is 1, 2, 6, 7, 8, 9. That is left hand side. A complement is 6, 7, 8, 9. B complement is 1, 2, 7, 8, 9 and union of that is 1, 2, 6, 7, 8, 9. That's RHS. From results we can verify that LHS is equal to RHS and that's why this rule is also true. Graphically we can write it like this: A intersection B whole complement. So everything which is not part of A intersection B will be the part of result. Cartesian product. So Cartesian product is defined as a tuple A comma B where small a element is coming from set A and small b element is coming from set B. So actually Cartesian product is set of tuples and tuple is an ordered pair. So first element must be from first set and second element must come from second set. Consider A is equal to ABC, B is equal to 1, 2. So to form A cross B, we have to associate each element of A with every element of B. And we have to form a pair. And all such pair will represent a set, that is Cartesian product. So A we have to associate with 1, A we have to associate with 2, and that process we have to repeat for B and C as well. So A Cartesian product B would be A1, B1, C1, A2, B2, C2. In set, order is not important, so we can shuffle the order of individual pair. So I can also write A1, A2, B1, B2, C1, C2. I can also write C1, C2, A1, B1, B2, A2. Any random order is possible. The only thing is that first element in every pair must come from set A, which is highlighted in red color. And second element must come from set B, which is highlighted in blue. Otherwise, individual pair we can put in any random order. But it is not same as 1A, 2A, 1B, 2B, 1C, 2C. Because we are computing A Cartesian product B. So first element in tuple must be from set A. Here it is coming from set B and hence A Cartesian product B is not same as B Cartesian product A. Partition of the set. Partition is represented by the symbol big pi, and we can say that pi is partition of set S if it satisfies following condition. The first condition is pi must be subset of power set of given set. Phi must not be present in partition. For all x comma y belongs to pi. So pi is actually a subset of given set. So x and y are some subset from partition. If we take any two subset, then they should not be same and their intersection must be null. And when we take the union of all the partition, it should form the original set back. Let us try to understand it with the example. If we consider the set A, B, C, D, E, F, then A comma C is a one subset of it, B, D, E is the another subset, and F is the third subset. If these subsets satisfy all four conditions, then we can say it's a partition. So first one, pi is subset of 2 power s. So definitely all the subsets coming from the power set of A, B, C, D, E, F. Because there are 6 elements, so there will be 2 power 6, that is 64 subsets of the set. And these 3 are definitely part of it. Second condition, phi should not be member of partition. So we can see that phi is not present. Third condition, if we take any two subsets, they should not be same. That implies intersection of them must be phi. So if we take AC and BDE, their intersection is null. AC and F, intersection is null. BDE and F, intersection is null. So third condition is also true. And if we take union of all the partitions, then it should generate the set S. And that we can see that AC union BDE union F will give us A, B, C, D, E, F set back. So this is a partition of given set. All four conditions must meet. If any one condition is false, then that partition is not the correct partition for the set. If we talk about this A, B, D, E and F, then it is not partition because the first condition is true, second is true, third is true, but fourth is not true. Because when we take the union of all these partitions, it is not forming set back because element C is missing into this. If we talk about this A, B, B, D, and F, then also it is not a partition because again C element is missing here. So union will not form the original set back. This is definitely a partition because set itself can be a power set of itself. So any such combination is possible. We can have a multiple partition for any single set. As we can see A, B, F, C, E, D, here we have 4 partitions and it is totally valid because all are satisfying the 4 conditions of partition. In other words, a partition of a set S is just a division of the elements of S into one or more group. It cannot be 0. And all the partitions of the set ABC, let's find out. So that would be single element partition ABC. We can have a partition of 2 elements, that is A, BC, B, AC, C, AC. And we can have a partition of element 3 as well. So these are the partitions of all possible partitions of set ABC. Let's just have a summary of all the operations we have performed. A is red, green and blue color, B is red, black and orange, and C is red, orange, black, green, blue and purple. The name of color are highlighted with the same color, so it's easy for us to understand or interpret. A union B union C will be all the colors in the universe, that is the union of red, green, blue, red, black, orange, and red, orange, black, green, blue and purple. A union B would be a combination or the union of colors present in set A and B. A intersection B would be the common colors in A and B, which is red. A minus B means we have to subtract all the colors of B from A. So red is common, so that will be subtracted and we are left with green and blue. A complement is all the colors which are not in A but present in X. So that would be black, orange and purple. Pi C means any partition. We can have multiple partition. One of them is shown here, red, black, green, blue, orange and purple. So when we take the union of all these partitions, it will form the capital X. A complement intersection C. A complement we have already computed, that is black, orange, purple, and intersection of that C would give us the common color in both, which is black, orange and purple. Let's test your learning. Question 1, differentiate set and Cartesian product. Question 2, how partitions is different from the power set. Question 3, find at least 5 partitions of set A, B, C, D, E, F. Question 4, differentiate absolute complement and relative complement, and you have to give example as well. Please mention your answer in the comment box. If you have any query or any confusion in understanding the answers of this question, please visit the link given in the description box where you can find answer of all the exercises on this subject. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.